to do the debugging, we can use VS Code. Okay, we can use VS Code. Okay, and let me create one file which is .py. Okay, I've defined a file, and let me write down a program equal to 90 def add b equal to 100 print b print a def inner c equal to 200 print b print c inner sub. Okay, so this is the code which I've written. Just randomly created some functions. Okay, randomly, like I just created some function over here, and on this function there are some, yeah. So created a function add, subtract, and inside add I have created inner, right? So these are the functions that is created. And now what we'll do, if I want to debug this, if I want to debug the code, then I need to put a breakpoint. Breakpoint is the place where your code is getting stopped, and from there you can start executing line by line. Okay, so if you look at this left side, here you can see the red dot, right? So this defines the breakpoint. So let me give the breakpoint in line number 1. Okay, after giving the breakpoint, we need to go to run and start debugging. Choose the Python file. See, so my program execution started, and the program came in, stopped at line number 1 because line number 1 had a breakpoint. Right? Now you just need to notice, or you just need to keep an eye on these 3 boxes: variables, watch, and call stack. As per the concept, whenever you execute the program, global memory gets created, right? This is your global memory module. It gives me 6 options. I can resume by clicking on continue. I can go to the next line, executing and go to the next line. I can go inside something. So if there is a function, I can go inside the function. I can come out of the block, come out of the function, restart and stop. So for now, if I do this, it will resume the execution and stop at the next breakpoint if there are any. If there are no breakpoints, it will just execute. So let me do this. What happened? First line got executed and this got defined a equal to 90. Even the function got defined. Sub function is also defined. Now I simply don't want to execute sub, but I want to go inside the sub and see how things are happening. So here I'll choose this one, go inside. It went inside sub. Now whenever you start executing the function, what happens? Function memory gets created, right? This is your function memory sub. Okay, sub is the function memory which got created. Now go to the next line. Inside the function memory, a d equal to 300 is defined, and in the global you have a equal to 90. It is printing over here, and from here let's go inside. When we go inside, it goes to the add function, and you can see that add function memory also got created. Right? Now, if you look at this, I can switch between the memory. I can switch between the memory. This call stack will tell you the sequence of the execution. So from call stack, you can understand that the function started from global module. From there, it went to sub, and from sub, it went to add. Right? And inside add, we have local memory as well as we have global memory. In global, a equal to 90 is defined. In local, b equal to 100 is defined. Now let me go inside this inner. Right? So we went inside inner. Okay. Now we have c equal to 200. Right? We have c equal to 200 in the local. And b, see, enclosing scope b equal to 100 is defined in the add function, but we are still able to see that in the c. Right? In the inner function, it is still coming. And closing scope always available for the inner function, which is the reason closure is working, right? In closure, what we are saying, we are returning the function, inner function, and even after calling the outer function, inner function has the context of the variable which we have defined in the outer function. Right? So that scope always remains. Now, when we execute this, inner memory got removed because the execution is completed. Even add function execution done, so memory is removed. Now global is also removed, function execution got completed. Right? Clear? So you need to go to run, start debugging, right? You put a breakpoint. Let's have put a breakpoint here also. You put a breakpoint. The program will start in the debugging mode. If I resume, it went to the next breakpoint and okay. Yes, so ideally what happens whenever we have any kind of program, real-time programming, then we define the breakpoints and start debugging. I'm using VS Code, not Visual Studio, but Visual Studio Code. Okay, so we put a breakpoint, go to run, start debugging. Right, this debugger will start your program, and it will stop at the breakpoint. Right, and from there you can start executing a program line by line. Right, and while executing, you can also check what are the variables that is getting loaded, right? You can also check basically the scope, call stack. I can also keep a watch. I want to see what is the variable a, or if a is greater than 45 or not. So I can define some expression in the watch and keep an eye. So whenever that expression gets changed, right, this will be updated. So currently it's not available. When I when I start the debugger again, it's not there, right? It got defined. So in watch we can keep the variables or some expression that we want to keep an eye upon, right? Clear? So with debugging in real time, if you have a program, right? What happens with debugging? You debug instead of we have like thousands of lines of code, right? You cannot go through each and every line. So that point we need to put a breakpoint, start the program, and when the breakpoint hits, from there you can start debugging, right? See, for loop, right? So how does a for loop work? It goes inside. Let me put the value of x also. Come back, goes inside, come back, goes inside, come back. See, x is changing. Okay, clear? Just try. If you have the VS Code, download the VS Code. If you don't have, set install Python in that, and then you can write a program, put a breakpoint, start debugging. Right? If you're not able to get the output, with debugging, you will be able to understand what is going wrong. If you have some code written which you're not able to understand, with debugging, you will be able to understand what is a flow. Right? So to become a good programmer, you should be a good debugger. If you are able to debug, if you know how to debug the code, then you can fix anything because you know what is happening, what is going wrong. But if you cannot debug, right, writing the program will be tough. You don't know what to write, where to write, and why to write. Right? So debugging is really very important. So start practicing debugging. Whatever code you write, even you can copy the code from online. Prime number, Fibonacci series, paste it, put a breakpoint and debug and see what is the logic they are executing. That will also give you idea on how the program is working, what are the concepts, because you'll get to know the working thing, right? You know that how does a while loop work. So when you start debugging, you get to know how does a while loop work, how does a function work, the flow sequence, right? So start debugging that, make that as a practice. Clear? Okay. Now, one of the important topic, one of the important topic is your OOPS concept. And as part of OOPS concept, we are going to talk about what is a class, what is an object, methods, properties, self, constructor, abstract class. OOPS principle, which is your encapsulation, abstraction, inheritance, and polymorphism. Okay. Now, what is a class? Class is a collection of features. This I have mentioned before also, right? In the initial session. Class is a collection of features. By feature, I mean it is a collection of methods and properties, right? So, what is a class? Class is a collection of. To create a class, we define class user. So this is how we create a class. Class followed by the class name, and within the class, within the block, define the methods. Okay. So class is a collection of features. Features means it's a collection of methods and properties. Methods are the functions. Properties are the characteristics which we'll see how to define, how to create the properties in using Python and what are properties. But class is just a structure, right? One thing what we need to take care is when you define the sorry when you define the class and when you define the method inside the class, every method has a first parameter as self. I'm passing self, right? Self is the mandatory parameter. You need to pass the first parameter of the method inside the class. If you do not pass, it will not work. Okay. Now, how do we use the object? We create the object of the class and then we do o dot login. How do we create the object? Object name equal to class name. So after creating the object, we call the method using the object dot. When I do object dot, I'll be able to see both, right? All the methods that I've defined inside the class will be available in the drop down, right? Right? Just execute this. Okay, so after defining the class, we cannot use the class without creating the object. Right? How do we create the object? Variable name equal to object name equal to class name. Okay? Once the object is created, then we can call the method. Now, one thing what we need to take care is that inside the class, right, every method that we create is a object binded. Right? So self is mandatory. Without self, we cannot create the object of the class. Okay? Without self, we cannot create the object of the class. So self is required. Okay? What is the self will always point to the object who is calling the method. Right? So in this case, in login, O is the self. Because who is calling login? O. Right? So O is self. Right? Similarly, let's say if I call using the class name. See, you look at the difference. When I'm calling with the object name, even though I have a parameter, I'm not passing any value. And it is working. When I'm calling with the class name, login, now your login method is confused because it is being called with the class name. And one class can have multiple objects. One class can have multiple objects, right? So it is confused now what needs to be done, right? So in this case, we have to explicitly pass. Okay, we need to explicitly pass the object reference. So self will always contain the object reference. Which object you are calling, from which object you are calling the method, that reference will be taken by the self. Then only in OOPS concept, one class can have multiple objects, right? So I can execute a method with object one as well as with object two, right? So how will you differentiate? How the class will differentiate that who is calling this method, right? So we need some reference, right? Object reference. Self is that. Self is not a keyword. You can define anything, but it should be consistent. It's not like in the first method you are defining self, in second you are calling it something else, right? So the concept here is the first parameter of the method inside a class is the binding parameter, and it binds to the object who is calling the method. Okay, it always binds to object binding. So self is the object binding. The first parameter is the object binding. Okay. Execute this. Okay. Got it? Self will see more with some more example. But when you are defining the function inside a class, first define the first parameter as self. Now, I want some parameter, some value also from the user. So then I'll define this. Now when I'm calling the login, I have to pass the value. Clear, right? Now with oops concept, we'll talk more about it, but with OOPS concept, there are four major principles that comes in picture. The first principle is encapsulation. What is encapsulation? By encapsulation, we mean that uh, the features that we are defining methods can be grouped under a class. So encapsulation means data packaging and data binding, data hiding, sorry, data packaging and data hiding. That means we can package the data, we can package all the methods by creating a class. So by creating a class, what I'm doing, login and logout, I'm packaging inside one group. So basically I'm creating a groups, right? I can create a class user, class payment, class order, class review, right? So I can create multiple classes, and each class can have its own set of features, right? Each class can have in its own set of features, right? The next thing what encapsulation talks about is data hiding. That means whatever I'm defining in the class, it is available in the object drop down, right? So if you do not want to provide everything to the object, then you can hide few of the features. So let's say I'm creating one more method, reset. I don't want to show this reset. What I can do, so I can put double underscore. First, let me try without putting double underscore. I'm getting reset, login, logout, all this, right? When I put double underscore, see, reset is not coming. So reset is hidden now. It is hidden, and who can use reset? Only within the class you can use that method, private method. Why do we need private method? We create a method so that we do not duplicate the code, right? So there's some logic which is being used in two functions. Better to create one common function and call that function in both the places. Now that function, what we created, reset, this is not a feature which can be used by the object. So I can hide this. I can make it private. So this is one feature that your OOPS concept supports, encapsulation. The next feature is abstraction. Abstraction means anything which is not hidden. Okay. Whenever the whatever is not hidden are known as abstraction. So what is abstracted here? What is shown here? Login, logout. So this is abstracted. What is encapsulated? Reset. Right? Anything that we are not hiding are abstraction. Right? Why it is known as abstraction? Because we can we can okay, why it is known as abstraction? Because we can use all the feature or none of the feature. There is no restriction, right? That I create the object. There is no restriction that I have to use login, logout both. I can use one of them or few of them. That means class is providing you all possible features. Now it depends on the implementation what we are implementing. But from class we are getting everything, all possible things. And whatever class is not giving that are those are encapsulated, right? So these are the two principles. The third principle is inheritance. That means if there are some feature which are being used in multiple classes, Then instead of redefining in all the classes, we can start inheriting. And how does the inheritance work? We need to make one of the classes the parent and the other will become the child. Right? Parent class can child can access everything from the parent class, but the vice versa is not true. That means child cannot access from parent. Sorry, parent cannot access from child. Child can access all the abstracted feature, not encapsulated, all the public, not private, all the abstracted feature of the parent class. Right? Now, how do we define the parent child class? So let me define one more class, employee. And if you want to make that as a child class, right, then within the bracket you can pass the parent class name. Now employee becomes a child, user becomes a parent, right? And let me define get employee. Now when I create the object of EMP, right, and then when I do this, see, I'm getting login logout from parent class, get employees coming from the its own class, and it is not showing me reset, right? Reset is not coming. Got it? Now inheritance are of multiple types. This is known as multi-level inheritance. That means one class is child of another class and that class is again child of another class. Like in university, college, department and student. Student is the part of department. Department is a part of college. College is a part of university. So student can access everything from department, college, university. Department can access everything from college and university. Department cannot take the data of student, right? The feature of student, right? This is known as multi-level inheritance. Okay. Then there is multiple. That means there is an employee who is part of two companies, previous employer, current employer. So there are two companies. Both the companies are not connected. But that employee is part of, since the employee was part of both the companies, so employee can access few things from both the companies features, right? So that is a multiple inheritance, right? And then there is a hybrid. Hybrid means I have one class which has two child, and from both the child I have one more class. Hierarchical, not hybrid, hierarchical one. Now to make this, to create the multiple inheritance, we give comma and provide the class name. Let's say manager. So there is one more class called manager, and within this class I define something. When I create the object, see I'm getting log which is coming from manager, I'm getting login logout which is coming from user, and get employee which is coming from its own class. So this is how we define the multiple inheritance. Okay. Yeah. We'll continue next session. This breakpoint, Sanjay, will put breakpoint this way. Like you can come to the this side below the. You'll see this red dot. Click on it. You'll get the breakpoint. Or you can go to run new breakpoint and inline breakpoint. So F shift F9. This will also put the breakpoint. Okay. Inheritance. We'll take some examples, Sanjay. Like I have a call now. So next session I'll explain inheritance and polymorphism again.